Thanks everyone. Thanks for joining this session. We are continuing with module 1, which is about introduction and history of Wi-Fi. This is probably the last session where we are going to talk about things around the technology. From next session onwards, which is on this Thursday, we'll dive deep into the core of the technology itself. But this is the last session where we're going to talk about things around the technology. Whenever I learn any new technology, I like to learn why the technology exists and who uses it, why it's being used, why it's useful, and in many ways, what is the entire ecosystem around it. So I like to learn all of those things, and that's why we are trying to go through these sessions. In the first session, we talked about history and evolution of Wi-Fi. In the last session, we talked about different topologies and different ways in which Wi-Fi is deployed. And then in this session, we're going to talk about how the Wi-Fi standards evolved, how do they work, how does the standardization process work, and there are a number of other organizations that are part of the Wi-Fi ecosystem, right, that are helping in marketing, selling, and advancing the technology of Wi-Fi. And so we're going to talk about all of those in this particular session. So this session is it's going to be fairly theoretical, so please bear with me, but I think it is very useful information. And you might hopefully learn a few things that you have not heard before. Right. So before we jump into today's session, just a quick recap of the session 2, the last session, which we did on Wi-Fi network topologies. In this session, we covered the various topologies in which Wi-Fi is used. We talked about infrastructure mode. We talked about ad hoc mode. We talked about repeater mode. We talked about mesh. We talked about bridge modes, in different ways in which Wi-Fi routers and access points are deployed and used. We talked about that. We talked about various deployment use cases for Wi-Fi. Wi-Fi is deployed in enterprises, in city-wide mesh networks. They're deployed in shopping malls, in stadiums, in multi-dweller unit scenarios. They are deployed in transportation, in airplanes, buses, trains, and so on. And of course, they're deployed in the house, in the smart homes, with smart IoT devices, and so on. So there are many, many different ways in which Wi-Fi is deployed. We talked about that. We talked about the various backhaul technologies for Wi-Fi, how Wi-Fi is backhauled over cellular, it's backhauled over Ethernet, fiber, coax cables, over power lines. So there are different ways in which the Wi-Fi network connects to the internet. We talked about that. We talked about network challenges, or basically wireless challenges with Wi-Fi and wireless in general. We talked about the idea of path loss. We talked about multipath, the security issues, quality of service, and many, many other things when it comes to technology challenges. And we also had listed a bunch of business challenges with Wi-Fi that needs to be addressed. Now, a lot of the technology challenges and business challenges are the problems with the technology, and most of these problems have been solved over the past couple of decades. And that is really what this course is about. And how did all these challenges get solved? What is the core technology behind how these problems are solved? And all of that, we're going to talk all those things in a lot more detail as we move forward. So anyone who has missed the last session, it's already up on the website. And this is how you access the website, basically. And then once you go to the website, the videos are uploaded there. The slides are uploaded, and class notes, we are going to upload the class notes also, written notes of everything that was told in the class. So all those things will be uploaded as we go. And if you have not registered for the class, or if you want to join this WhatsApp group that we have, where we are discussing various things about this class, we are posting questions. If there are any questions that have been posted, we are answering those. We are providing updates about various things. I think this group already has about 900 people in it. So we'll try to keep this group more active. We'll also post some reference material, some other additional training material that's available that you can use if you are new to Wi-Fi. All those things we'll continue to discuss in that group. Okay, just jumping right into the topic. Today's topic is WLAN standards and amendments, and the various things around the WLAN amendment. So what is a standard? What is an amendment? How does that work? How does the standardization process work? We'll talk about all of those things. First of all, why do we need a standard, right? That is important to understand. So if you take a simple example, let's say in my family, let's say there's a family of 4 that live in a house, and they speak a language, right? And they develop that language by themselves. So there are certain words, and words have meanings, and all 4 members of the family understand that a particular word means something, right? Like a phone means this device, right? So they have this protocol or this agreement that they have developed of what a particular word means and what it sounds like and how does the grammar work. And if I developed a language like that only the 4 of us can understand in our house, then we can communicate with each other quite well. But no one else outside the house will be able to understand what we are saying, or will be able to communicate in our language, right? So if we want widespread adoption of any particular technology or protocol that is exchanged between 2 different people or 2 different devices, we need a standard, right? For example, this access point needs to talk to this device. This device should be able to, this access point should be able to talk to hundreds of devices like this all around the world, right? Same way, this device that is working on the Wi-Fi network should be able to talk to hundreds of access points from different companies all around the world. How is that possible? The only way that is possible is if there is a standard that is defined that both these devices will follow. For example, going back to the same example as I told you before, if we take the English language has a particular standard to it. There is a dictionary, there is a vocabulary, words mean something, it has been written down, grammar has been written down, what's right, what's wrong has been written down, and it is a pretty much standard that entire world agrees to, right? So now if I want to communicate in English, I can go to the standard and learn English, and now I can communicate with anyone else who actually knows English in this world. So that is how standards are developed. Like you create a certain set of guidelines and rules that everyone follows, and so they can communicate with each other, right? And that's how wireless LAN standards have been developed. If you look at the history of wireless LANs, in the first session I was mentioning where the Wi-Fi technology just started, there was really no standard. This was in the early 1990s. So people started implementing proprietary implementations. They actually developed their own implementations. We talked about how a Wi-Fi network was set up in a university, right? But that was limited to that university, right? Only the devices in that university can talk to each other, right? But for it to be adopted all around the world, it has to be standardized. And at around the 1999, 97 time frame, the first standards came out, and then that really triggered the widespread adoption of WLAN or Wi-Fi, right? So we're going to talk about the standardization process in this particular session. So there is something called IEEE 802.802 standards, and there are many 802 versions here, and this information has been taken from Wikipedia. So all the way from 802.1, 2, 3, 4, and so on. The most notable ones here are 802.3, which is the Ethernet technology. So we all know Ethernet. Anyone who is used for networking, we have Ethernet cables that we use to connect to the internet. And so the Ethernet technology is 802.3 standard, and that's still active. A lot of these other standards that have been developed over a period of time have been implemented, but did not find a solid business case, right, to get widespread adoption. So technologies like token ring and token bus and all these other technologies have been disbanded or basically stopped because that technology that was developed did not find a proper use case over many years of time, and they did not get standardized for a long time. And so there are lots of standards that have been developed and they have been disbanded, right, over a period of time. The ones that survived are 802.3 in this case, and then 802.11 under IEEE, which is the wireless LAN standard, right? We call it Wi-Fi, but 802.11 is the official name, and we all refer to it as wireless LAN, which is the wireless extension of the LAN, or a wireless extension of 802.3, right? The other standard that survived is 802.15 that you can see in this list, wireless PAN. And under this, you have Bluetooth, and you have other technologies that are for personal area networks, right? So that is also very much a standard that is very active, and there are lots of applications and implementations around it. There were other technologies like WiMAX 802.16. This was for broadband wireless access, and the idea of WiMAX was to in some ways compete with the cellular network and the LTE technology. that also did not survive. And there were at one point there were many companies that were trying to implement WiMAX technology, but because of various business complications and high cost to actually set up these networks and so on, that standard did not survive and did not get implemented in a wider way, right? So 802.16 is also in some ways in a hibernating stage, right? But to really look at this, if you look at the IEEE standards, the 802, the ones that survived are Ethernet, WLAN, and in some ways the WLAN, the Bluetooth standard, right? So if you look at the diagram here at the bottom right-hand corner, a lot of these wireless standards are based on distance between the transmitter and the receiver, right? So let's assume the transmitter is here and the receiver can be at different distances from the transmitter, and that is what the standards are based on. For example, in very close proximity, my mouse or my keyboard connecting to my monitor or my computer, right? That is where very close proximity, right? So under very close proximity, we have technologies like NFC, we have RFID, and so on. If you go a little bit far, like around 10 meters range, 10 to 100 meters range, then we have the wireless personal area networks, or under this you have Zigbee, we have Z-Wave, we have Bluetooth to some extent, and all these other technologies as well that are part of wireless personal area networks. That is short range, right? For short range communication, where a device can talk to another device wirelessly, right? And then little bit longer range, we have wireless LANs, which is about 100 meters to up to a kilometer range if you're doing it outdoor, and you also have outdoor implementations for Wi-Fi. So that's where you have all the wireless LAN protocols, right, in that space. If you go a little bit farther, then you have wireless neighborhood area networks, some technologies there that are not really that famous, but there are some standards around it. And then the farthest, of course, is the wireless wide area networks, under which you have cellular, LTE, and LTE unlicensed, and all these other things. And then if you go a little bit farther away from that, then you have satellite communications and so on. But this is the kind of the range for which the IEEE standards normally work in. Okay, so the standardization process itself is actually quite interesting. So early on in my career, and one of my very first jobs is to be part of a research organization that gets involved in the standardization of Wi-Fi. And so I used to get a chance to attend these standard body meetings, and it was quite interesting. Being a technical guy, I found these meetings quite different from what I was expecting, right? Because the people who attend these meetings are the most experts in this area in this entire world. I mean, these are the best people, the most knowledgeable technical people from all the companies that are participating in the standardization, and they all come and meet. And then there are really two aspects to the standardization process. One is the technology aspect, and then the other is the political aspect. So there is a political aspect to it. Why is there a political aspect? Because there are literally hundreds of companies and thousands of stakeholders that are involved in this process, and everyone wants to get their technology into the standard. So let's assume that company A has developed a particular type of technology and they've patented it, and they are already implemented it, and they have an edge in that area, right? So they want to try their best to get that particular technology into the standard so that everyone else has to use it, right? So there is some form of, to some extent, some lobbying that happens. Let's say there is some organization that is delayed in implementing a particular type of feature. They will sometimes may try to actually slow down the standardization process until their technology catches up to the delays, and then there could be a deliberate way of to some extent trying to actually delay the standardization process. These are all the political aspects of the standardization. But of course, there is a very strong technical aspect to standardization, which is where all the companies come together, the experts come together, and they start with an idea. Like, for example, let's say we're using a certain type of security. All of us, when we connect to the Wi-Fi network in our houses, we use WPA security method, right? So we type in the key and it connects to the network. Let's assume that that particular WPA method is not a safe method anymore. Someone figured out a way to crack those keys, right? Fine. So now you need to develop a new security standard that is even more robust. Or let's say now we are having these AR, VR applications, and we have OTT platforms in the house. So which means that we are trying to stream 4K, 8K, ultra high definition video streaming, where there are 30 other devices that are connected in the house. So we need a very low latency network, right? So the latency has to be very low on my network to actually carry out these applications. So that is a requirement. From that comes an idea, and then from that comes a document that says this is how you actually make Wi-Fi even more low latency, or this is how you make Wi-Fi more secure. And this is the algorithm, this is the protocol, this is the technology. And someone comes up with this idea and writes down a document, or a group of people come together and write down a document, and they put it up for authorization, and it's called the project authorization request, or the PAR, right? Someone asked what is a PAR in one of the previous sessions. That's what it is, right? So they come up with this requirements document based on an idea, and then they submit it to the standards body for standardization process. So from the PAR, then there is then once the standards committee sees, okay, this is a useful idea, right, and they vote on it and say, okay, is there enough interest to carry this forward into a standard? So then they'll try to ask all the member companies, okay, here is the project idea. How many of you think this is useful, right? How many of you are interested in carrying this forward? And if they get a majority vote, then say, okay, fine, there is enough interest. So let us try to move forward and create like a task group. So initially there is a study group. The study group studies the idea, right, and make sure that it is feasible, all the technology is possible, and everything is thought through. And then once the study group finishes its study, then there is a task group, and the task group is tasked with taking this particular idea through the standardization process, right? And the standardization process goes through many drafts. So initially they'll come together and put together draft 0.1, right? That is a very early version of the spec, right? And then they're going to have meetings on it, and then they're going to look at every little feature and say, okay, the initial version could have like 100 items in it, or 100 features. Which ones are mandatory? Which ones are optional? So they're going to debate on that. They're going to discuss on that. They're going to vote on that. And eventually it goes through several steps. It goes through draft 0.1, draft 0.2, draft 1.0, 2.0, 3.0, and that it goes on for multiple years, right? And as they go through the various drafts, there is voting. And then as the voting process goes through, eventually after about 4 to 5 years, this process takes, then they publish the standard, right? And then once the standard is published, then you need to go back to the cycle, and you actually revise the standard as needed, and so on. Like if the standard is not being adopted in the worldwide, then you may have to withdraw the standard if there is no enough interest in people. All those things keep going on as a part of the standardization process. Right? As I mentioned, as a part of the standardization process, there is a study group. The study group is responsible for taking an idea and creating a PAR out of it. And the task group is there, which is basically takes the PAR, and it actually starts taking it through the standardization process. And there are IEEE working groups. A working group is a combination of all these groups: task group, study group, and so on. There is something called as a topic of interest group, or TIG. A TIG is basically even before the study group. So that is basically studying the idea. So the TIG studies the idea, the study groups studies the feasibility of the idea, and then the feasibility is taken care of, and then it's handed off to the task group, and task group takes it through the process of standardization, right? And there are other terms like the standing committees and all of these. It's part of the standardization process, and all of that, to organize all of this is the political part of the standardization process, right? And remember that Wi-Fi is now well over $1 trillion market, right? There are literally thousands and thousands of stakeholders, hundreds and hundreds of companies that are depending on building a business around the standardization of this thing. So there is a lot of interest, and so because of that, a lot of people get involved. And I remember sitting in these meetings where you have a 1-hour meeting with very, very technical people, and these are all PhDs and they are experts in the technology area. and they sit for an hour and they discuss a particular line in the document. Should it say must or should it say should in that line, right? Because if you say should or must, that changes the meaning of the spec, just one word, right? And everyone could interpret it differently in the implementation, and the implementations will change, right? So each and every word, each and every sentence is important, and it needs to be clear, and it should be very precise. So a lot of time is spent around the grammar, getting the words and everything right in the standards, and then a lot of deliberation, a lot of back and forth, and a lot of voting. All of these things take place in the standards bodies. Of course, there are a lot of member companies. I took this slide from one of the IEEE meetings that is publicly meeting notes that is available. You can see that lots of companies participate, and they all have voting rights. Depending upon the number of members that come to these meetings, they have so many votes, right? So you see companies like Huawei, Broadcom, Qualcomm, MediaTek, Apple, NXP, Samsung, Intel. They're all members of this standardization process, and they all attend these meetings, and they are all contributing to the standard. Everyone is contributing some part of the spec, and then they're all voting on the different parts of the spec as well. If you look at as an example of 802.11be, which is the current standard that we are looking at, which is also called as Wi-Fi 7. This is the general timeline of Wi-Fi 7, right? So it started with the TIG, and then it went to a study group, and then it became a task group, and then around May 2020 or so. And then from then on to like right now, where we are in the October-November timeframe, we are around draft 3.0 stage, right, for Wi-Fi 7. Remember that not everyone waits for the final standard to implement and release products. A lot of the products, especially the residential access points or residential Wi-Fi routers, are released in the draft stage, right? So we had products in Wi-Fi 7, for example, even in the early part of this year and towards the end of last year, even in this time frame, draft 2.0, we had products that you can buy in the open market, right? So there are several companies that released Wi-Fi 7 products, and it most likely, if you look at the fine print on the back, it will probably say it was implemented based on 802.11be draft 2.0, right? And even the phones that are released, the devices that are released, also will be based on the draft, so that they can still basically talk to each other. It's not fully standardized, but it is like towards getting standardized, and the devices both talk the same spec, so they can still operate with each other. And this allows many companies to release early versions of this product and try to get a little bit of advantage in time to market, right? I think, as far as I know, I'm not sure if this has changed recently, but it looks like the Wi-Fi 7 standard, the final amendment where it becomes a proper standard, is going to come out sometime in mid or late 2024, next year, right? That's the timeline. As far as standards document goes, it's again quite interesting. And when I was starting my career in Wi-Fi, I actually used to go read these standards documents, and it was very hard to read for me at the time, because the documents are really hardcore technology, and for a beginner, it's very, very hard to read and understand what is written in these documents, right? But I mean, I had access to these documents. I used to read them. So all these documents, if you are part of the IEEE, if you're a member of IEEE, you should be able to go download all these specs from the internet, and these documents are usually thousands of pages long, right? And you can go through them, and everything that we learn in this course, and everything there is to learn about Wi-Fi technology is normally in these documents, right? And they should be quite interesting, right? So this is an example of I guess the first page of the draft, the standard from 2007, I believe. So IEEE 8.11 2007. So you see all the table of contents. For anyone interested, I think I put in the reference. Someone uploaded this .11 2007 standard, so I put a link to that in the references. So someone, if you wants to download this document, you can go download that. I think the newer versions, to download them, you need to be a member, you need to purchase them. But older versions are somehow available on the internet. So you can certainly go download them and go through them if you're interested. Okay, so I'll talk a little bit about, maybe I'll jump to the news slide first. So the way the standardization works is there is the base standard that was developed. For example, 1997, there was a base standard that was developed that was extended in 1999. So what happens is once you develop a base standard, the standard is developed based on the use cases that you have at that point in time. So for example, the base .11 standard supported up to 11 Mbps, and it supported a certain type of spectrum technology, right? And it was only for 2.4 gigahertz band, right, in the ISM band, right? Then after that, the government said, okay, you can use uni bands or 5 gigahertz bands for Wi-Fi. Then there was more applications that came along. Then there is new technology that came along. Then there are more use cases that came along. So as these use cases, business cases, and technology came along, what the standards body will do is they will work on these amendments. They call them amendments to the standard. For example, 802.11a is an amendment. 802.11b is an amendment. 11G is an amendment. These are all amendments, right? And what is an amendment? An amendment is a particular use case that is a new use case or a new business case, and the technology behind that needs to be standardized. And eventually it can get rolled into after it goes through the same standards process. By the way, every amendment that we have, it needs to go through the same process. It needs a TIG, it needs a study group, a task group, and standardization and all of that. And once it's all done, then eventually it gets rolled into the main standard. For example, in 1999, there was a version of the main standard. And then over in 1999, 2003, 2004, 5 time frame, there are all these new amendments that came out. And then in 2007, all of these got standardized over a period of time and got rolled into the main standard .11 2007, right, which has all these extensions built into it, right? Similarly, in 2008, 2009, 10, 11, there were a number of extensions to solve various real-world use cases, right? And I'll talk about what these extensions are and what problems they solve, right? And then as we started building these use cases and extensions, there is again a committee that forms, they standardize it, and then it gets rolled into the main standard again, right? Again, the same process repeats. 2016, there was a new 2021, and eventually in 2024, there will be a new base standard. This document is going to be super huge. It's going to be multiple thousands of pages because it has all this technology across all these 20 plus years, the 25 years or so that is rolled into the spec, right? So that is generally how the WLAN Wi-Fi standardization process works, right? So now going back to what are all these extensions, right? As I mentioned, the base standard came out in 1997, and they did like 1 Mbps and 2 Mbps and 2.4 gigahertz frequencies. It got extended to 1999 standard where they added 5.5 and 11 Mbps data rates in 1999, and that is also still basically the base .11 standard. And then in 1999 or 2001 timeframe, these standard extensions started. So now the 5 gigahertz spectrum got available for Wi-Fi. So then they started implementing this .11a standard, which allows you to use Wi-Fi in the 5 gigahertz spectrum, and it will allow you to go up to 54 Mbps 5 rates, right? And so how did you get to 54 Mbps? We started using this OFDM technology. And again, we'll talk about all of these in a lot more detail. If I am mentioning terms that you don't understand, don't worry about it. They'll all be covered in the coming sections in a lot of detail, right? I'll explain the spectrum technology, OFDM technology, OFDMA, what are the fundamentals, how does the technology work, all of those things I'll explain in the coming sections, right? 11B, although 11B came out first, and it's interesting, even though 11A was allocated first, 11B came out first. And 11B was doing this 5.5 and 11 Mbps data rates in the 2.4 gigahertz band, and then 11A was doing 5 gigahertz. And then as we went along, there were new requirements. For example, there is a requirement for quality of service, right? The base standard does not support quality of service, which means that it treats all type of traffic the same way. For example, if I have a device and I'm trying to do a video call, or I'm trying to send an email, or I'm trying to make a voice call, it does not matter. The base standard will treat all those traffic streams the same way, right? Which was fine in the early version of the standard, because in 1999, no one was doing video calling over Wi-Fi, or no one was actually making phone calls and audio calls over Wi-Fi. So there was no necessity to have quality of service, right? All you're doing was sending emails. So if your email was delayed by a few milliseconds, no one even noticed and no one cared. So there was no need for quality of service at the time. But as we went along in the early 2000s, people started doing voice over Wi-Fi, right? So now quality of service becomes important. We need to make sure that when there is a voice call going on, if someone else is trying to send data, the voice call gets higher priority, right? So you need to amend the standard to be able to do this function, which did not exist in the base standard. So from them, that comes an amendment, and they called it 11E. And the 11E is, its whole charter is to implement QoS in .11. And there was an entire document around it that took multiple years to standardize, and multiple companies participated. Now, after it became a standard, then it got rolled into the base standard, right? Similarly, we have security. If you look at .11i, the base standard was using open authentication, and it was also using something called as WEP, right? Which was you can easily crack it, and it's easily susceptible to attacks and things like that. So then they wanted to make it more robust, because Wi-Fi was starting to get implemented in enterprises, in offices. And when you have a Wi-Fi network in an office, you need to make sure that the network is secure. So security became suddenly an important thing, right? Without security, you cannot use Wi-Fi. So the companies came together and said, we need a standard extension for security, and they called it .11i, called enhanced security. And then they went to the same process standardization again, and then 11i became a standard, right? You can look at several other examples. Radio resource management, 11K, right? This is again a very interesting use case, because the original standard, they never imagined that you would have more than one access point or Wi-Fi router in a location, right? But now, if you look at, as you went and started implementing Wi-Fi in enterprises, people started deploying lots and lots of Wi-Fi routers, because they want to cover more space, they want to provide more dense coverage to more users. And so suddenly radio resource management became a problem, right? So now there are only limited number of frequency channels. Remember, we are using unlicensed spectrum, so there is only limited number of channels, but there are lots of access points, right? So now how do you make sure that all these access points are using the best available channel without interfering with each other, right? And how do they automatically do that, right? So there is something called radio resource management, and there are some protocols that need to be implemented, right? And to implement those protocols, they started this standard extension called 11K, which is for radio resource management, right? Similarly, there are so many examples. Okay, so as they went along, they said, oh, no, 54 Mbps is not enough. That's too slow. I need 500 Mbps, or I need 600 Mbps, right? So they wanted more speeds. So then they started this high throughput wireless LAN, which is .11n. And .11n introduced the concept of multiple input, multiple output, or MIMO, where you can use multiple antennas to transmit and receive, and effectively increase your throughput. They also introduced this concept of using wider channels, 20 megahertz, 40 megahertz channels, and so on, right? So then that became a new standard extension, 11n. 11p, we talked about 11p in the last session. This is vehicular Wi-Fi, right? That also is about implementing Wi-Fi technology in vehicles. Then we started seeing roaming as an issue. And again, if you look at an enterprise, let's say you have a secure connection to an access point, and you're doing like a web conferencing or a video call, and you're moving from one place in the office to another place in the office, which means that you will move from one Wi-Fi access point to another Wi-Fi access point while actually carrying the call. So how do you make sure that you don't lose connection? You need some way to very quickly transition from one access point to another access point while the connection is still secure. You need to actually take the keys, encryption keys that are using with the current AP, and move those encryption keys to the new AP very quickly without actually losing any connectivity. So how do you do that? There has to be some standardization, some technology behind it. And so that is part of 11R. Mesh networks 11S, hotspot technology, seamless, anywhere we go to hotspots 11U, wireless network management 11V, protected management frames 11W. Like that, there are so many use cases that came along, and for each use case there was a standard extension or a standard amendment and a standardization process for that. Now all the alphabets in A through Z or A to Z are all done. So now they went to like 2-letter words like A, B, AC, AD, and so on, right? So of those letters, AC, 11AC is a very well-known standard, which is your Wi-Fi 5, basically your very high throughput standard, right? So this one came in and it went up to over gigabits per second throughput, right? So 11AC came out sometime in the 2013-2014 time frame, right? So 11AC is a notable one, right? 11AD, some of you might know, it's called WiGig, which operates in the 60 gigahertz spectrum, right? Similarly, there are other standards. If you go down the list, they're all different use cases for different applications. And then the other notable one here is 11AX, which is the high efficiency WLAN or Wi-Fi 6, right? And it introduces this OFDMA technology. And this standard came around the 2021 timeframe. And then the other notable one here is 11BE, which is now still in progress or process. And this is extremely high throughput, right? Now we're talking about close to 50 gigabits per second throughput, right? And this is the BE technology, right? And this is again going to be standardized somewhere in the 2024 timeframe, right? So these are all interesting standard extensions, and it's very fascinating to follow this, especially who are interested in the core technology of Wi-Fi. There is so much process around how this standardization actually works. Okay, so that is the IEEE, right? So this is the primary body that develops the core standard, right? But then to actually adopt the technology, there are lots of other players in the ecosystem. Remember that this session is more about explaining everything about the Wi-Fi ecosystem, right? And we're continuing to do that in this session. So one of the key players in this ecosystem is the Wi-Fi Alliance. So what does Wi-Fi Alliance do, right? So if you look at the base standard, remember I said the document is extremely complex. It has thousands and thousands of features in it. It is very hard for a normal person, average person like me to read, right? So what does Wi-Fi Alliance do? Wi-Fi Alliance is a little bit of more of a marketing organization, although they do a lot of technology, and they try to simplify the standard for people, and they also help with certifications, right? So that's one of the main things that that Wi-Fi Alliance does. In fact, Wi-Fi Alliance is the organization that coined the term Wi-Fi, right? And they try to make a lot of these things that are complicated easy for people to understand. So we said 802.11be, right? So that's not a very easy thing to say, right? I'm not going to say I have an 802.11be Wi-Fi router, and it's not that easy for a normal person to say that. It's a lot easier to say I have a Wi-Fi 7 router, right? Because Wi-Fi 7 is a lot easier to remember than 802.11be. So Wi-Fi 7 is a term that was coined by Wi-Fi Alliance, right? So they try to make these things simpler, and they also want to make the standards simpler. Remember that each one of these specs literally has hundreds of features that are proposed and standardized, but not everything is going to make it into the final product, right? So almost only about 10-20% of the features that are in the original spec actually get used and implemented and used in the real world. So what are those 10 or 20% of the 100? So Wi-Fi Alliance helps on standardizing those things and say these are the things that are important, and there are companies that meet along those lines. And then as the standard process is going on, Wi-Fi Alliance will also help with what we call as plug fests. So early version of early implementation, so draft 1.0 implementation, draft 2.0 implementation. They will allow, for example, let's say this access point is made by Qualcomm, and let's say this station device is made by Broadcom. So they will allow Broadcom and Qualcomm to come together and run some tests, and to see that early version of the standards, there is interoperability. So this guy can talk to this guy and communicate and then pass traffic, right? So basic interoperability. So they try to do interoperability testing as the standard gets implemented, right? So simplifying the standard, testing and conducting plug fests and helping with interoperability and creating various forms of certification. So if you go to the Wi-Fi Alliance and let's say you build a Wi-Fi 7 router, you can go to the Wi-Fi Alliance and to one of the authorized labs from Wi-Fi Alliance and get a Wi-Fi 7 stamp or certificate, which means that you can take this and they will test it and they'll run all the different types of tests as a part of the test plan, and they will say, yes, this device is Wi-Fi 7 capable and it can interoperate with another device that uses Wi-Fi 7, right? And then you get that Wi-Fi logo on this one, right? So that standardization process and certification process is also done by the Wi-Fi Alliance. So under the Wi-Fi Alliance, there are several certifications you can get. There's Wi-Fi 6 certification, Wi-Fi 7 certification is in process right now. If there is a security, like WPA3 is the new security standard, so you can actually go get your access point certified for WPA3, right? And then Passpoint, a number of other features that are available, right? A number of other applications for which you can get Wi-Fi Alliance certification, right? Wireless multimedia or WMM, if there is a QoS spec. So remember what we called QoS in the IEEE standard, we called it 802.11e, right? So instead of saying 802.11e, Wi-Fi Alliance has created a term called WMM or Wi-Fi multimedia, which is nothing but 802.11e, right? And so they created a testing standard around it. So basically you can run the test plan and you can get WMM certified, right? Similarly, we had .11i, 802.11i, so that is for security, and Wi-Fi Alliance called it WPA or Wireless Protected Access, right? And there is a certification for that. And so trying to simplify the whole technology and also create some certifications around it is primarily what Wi-Fi Alliance is doing. And then there are more other organizations that stepped in. Wi-Fi Alliance is one of the early organizations that stepped into this whole process. But then there are other organizations such as Broadband Forum that they recently came up with this TR398 certification for residential access point performance testing, right? So the idea is, for many years, a residential access point was expected to be a cheap device that is going to provide internet connectivity to one or two devices in the home. But now that has completely changed. Residential access point is very expensive, needs to handle 40, 50 devices. It needs to be able to stream like 2 or 3 OTT platform streams. It should be able to do AR, VR. It should be able to support all your IoT devices in your home. It should be able to do a lot of things, right? And so there is a requirement for proper testing. So Broadband Forum came up with this testing standard called TR398, where you can actually test the performance of coverage, RF performance, bandwidth, stability, capacity, all these areas you can test. And you can actually use this test plan, get tested, and get certified, right? So Broadband Forum is doing that. There's also WBA or Wireless Broadband Alliance, which also has various work groups and projects that help with the collaboration and standardization and implementation and plug fests and all these other things. This is the IEEE standard is a document, right? It is theory, right? And it is telling you what needs to be implemented, how it needs to be implemented. Everything after that I'm talking about is all practical. This is all implementation. This is all this is when the rubber meets the road, and when the technology is implemented, are the devices working with each other. So these organizations help with the implementation and testing during the implementation and proof of concept and all these other areas. So Wireless Broadband Alliance is one of those organizations that do that. Other parts of the Wi-Fi ecosystem, these are while we have the standards body doing that, while we have certifications body doing the certifications, and then there is all these resources and educational bodies or organizations that are trying to educate people like you and me about Wi-Fi. And there are lots of various outlets like this. WLAN Pros is one of them, where they meet, I believe, 2 times a year or 3 times a year in some location, and all the experts come and they present about the technology. They present about how to troubleshoot Wi-Fi networks. They try the different kinds of problems that they see in the real world in implementations, how those problems are solved, new ideas, and all of that. All of these are presented. So anyone who is actually interested can certainly go to WLAN Pro's website, and all these videos are all uploaded on their website. I might have posted a link in the references section. I find this very useful, and whenever I have time, I'll go watch some of these videos. They all have 10-minute talks, 20-minute talks, short talks on various topics. And certainly this will help you get up to date on what's the latest going on in the real world in the case of Wi-Fi. So certainly it's suggested to check that out. Similarly, there is something called as Mobility Field Day as well. This is something also you can check out, and similar to what I mentioned. This is where multiple companies come to this outlet, this forum, and they present the latest things in their products. Like example, in this case, you see Juniper, right? Juniper is presenting about all their new AI technology and all these other things they've introduced, and a lot of information is here, right? I used to get a lot of my knowledge from these Mobility Field Day videos. Again, all these videos are also posted online, and this allows you to understand what features the companies are actually implementing. And as I said, if there are 100 items in the standard, the companies that are actually using the standard would probably implement 5 or 10. And what are actually being implemented, right? And what else is they're adding on top of it. These are all the things you can learn through these forums. There is also something called as OpenWiFi technology that is we are also personally quite involved in this. This is a project where a few companies came together and said, let us make Wi-Fi technology open source. So for many years, Wi-Fi technology was pretty close. Like there's a company like Cisco or Aruba or someone like that. They take about 10-20 years to develop the technology that goes into this Wi-Fi router, right? I'm not talking about the base chipsets that are developed by companies like Qualcomm or Broadcom, right? The firmware and the software that goes into this access point is proprietary to TP-Link in this case, right? So they own that software, only they know it, and when they distribute their software, they distribute it as binaries, so you cannot decode it, and no one else can understand what it is and use it. So what happens when you do that is it gives you an advantage when compared to someone else. Let's say tomorrow Sitaram wants to start his own Wi-Fi access point company. For me to develop a Wi-Fi access point, it might take 5-10 years. It might take a lot of investment and cost, right? And if I don't see enough business advantage, I might never do that because I'm worried about all the cost all the R&D costs that I have to go through. So because of that, the number of people coming forward to implement the technology is going to be less. And if it is less, then there will be only fewer players, only fewer companies that are making these access points and routers. And so if there are only less players, then that particular market allows you to, it's considered as a specialized market, which means that companies will charge a lot of money to actually sell this Wi-Fi router. And so if it costs a lot of money, then it's not going to be adopted by widespread adoption, right? So the idea is to get the technology to get adopted in a much more widespread way. And the best way to adopt any technology in a very widespread way is to open the technology and make it open source, right? So the idea here is this community is basically open sourcing all the software firmware that runs on this device, something like this. Some community comes together, they write all the develop all the software, and then they put it up on the internet, right? And so if I'm a new person who wants to start a Wi-Fi access point company, I can go get some hardware that is certified by OpenWiFi. I can put my logo on it, and then I can go to become a member of OpenWiFi, get all the software, load all the software on it, and then put my special spin on it, and then now very quickly I have my own company, right? And so this allows more players to get into the market, and this commoditizes the market, and it gets more widespread adoption. That's the whole idea behind OpenWiFi, right? Similarly, there is something called as PM-WANI for those who are in India. So this is where really the government is trying to help, right? Especially in a developing country like India, what the government is trying to say is, wait a minute. I mean, like we have all these big cities like Bangalore, Hyderabad, and all these other places, and they are very well connected, right? So of course, there's a huge concentration of population of people in these areas. We have a lot of technical people and all of that. But what about the remaining 70-80% of the country where there is no proper infrastructure when it comes to the internet, right? There might be some cell towers in various villages, but that is not enough to provide broadband internet access to people, right? So how do you improve the economy of the company in this modern world where everything happens on the internet, right? Everything happens on the internet today, right? So if you provide internet everywhere in the country, and if all businesses run on internet, then that will help the businesses run faster, and so it will become more efficient, and it will contribute to the GDP of the country. So the GDP of the country in many ways is dependent upon how well the network is connected, right? And so because of that, the government of India has came up with this idea called PM-WANI, or Prime Minister Wireless Access Network Infrastructure interface, right? Where you can basically the infrastructure was standardized, and there are organizations like CDOT and a few others who are helping with the standardization of the infrastructure. But then the end user can get something called as build something called as a PDO, or a public data office. So for those of you who remember 15, 20, 30 years ago, we used to have this concept of public telephone booths. So there's these yellow booths where you can actually go and make a phone call. You can make a phone call locally or internationally, and so on, right? This is before the days when you had cell phones, right? So that's called a public telephone booth. And that public telephone booth gave you access to the world via voice, right? Same idea, you can actually build a PDO in the village panchayat or village revenue office or something like that, or any small location in a village or a small shop or something like that. In various locations, you can create these PDOs, and they're all connected to an aggregator, and then there is a central registry, and then the central registry manages all of that, and it allows people to actually get these PDOs and implement them in various locations, and the technology is democratized, right? And so each PDO will be able to charge for the Wi-Fi network if they want to charge for it, right? And so that's how they're encouraging the various places in the country to actually provide Wi-Fi access. If you are in a, let's say, in a coffee shop, like the roadside coffee shop, like or a tea shop in India, imagine if you had internet access there, right? Then you will have a lot more people who would want to sit there because there is internet access, and they will basically drink coffee and tea and snacks and whatnot, and that improves the business of that particular location. So either way, providing better network connectivity will provide overall better business, and that's the idea behind PM-WANI. I think I put some links in the references. If anyone is interested, don't know about this technology, you can certainly follow it. It is kind of in the kind of mid-level implementation stage. There are some places where the networks are installed, but still it has a long way to go. And then in the ecosystem, there are other marketing agencies or organizations like Wi-Fi Now, as an example. They are actually conducting these large-scale meetings at various locations in the world, where all these companies can come and they can, like a trade show, right? They can showcase their products, they can have booths, they can present the technology, and this is trying to actually bring the entire ecosystem together from a marketing and an awareness point of view, right? So trying to make more and more people aware about the technology and so on. So there are organizations like Wi-Fi Now. There are also nice podcasts as well. Clear to Send is one of them, but there are other podcasts that people are doing. Given that Wi-Fi is getting so much adopted all around the world, right? And there are so many people working on Wi-Fi, all these things will come because there is a need for that. And so there are now podcasts that are focused on Wi-Fi. Clear to Send is one of them, and they talk about different technical challenges, solutions, and so on, right? And then another part of this ecosystem is the organizations that are providing certifications. So if you are a professional, remember that this is a well over $1 trillion market, right? And there is so much ecosystem around it. And so which means that someone who knows this technology is probably highly employable, because so many employers need people who have the skill set around Wi-Fi. So how do you show that you have your skill set? Naturally, you would go for certifications, right? So there are certifications bodies like CWNP, which is a little bit of more of an industry neutral certification body that actually gives you certificates in various areas. Some of you who are attending session might already have some of these certifications, right? So there are certifications like CWNA if you want to get into the network administration side as a network administrator. But if you want to go more to the security side, there is Wireless Security Professional. If you want to understand the protocol, the technology, and a lot of other things we're going to talk about in the rest of this course, there is the CWAP, or an analysis professional. If you want to design Wi-Fi networks, how to place APs, where to place them, in how do you plan for capacity, how do you plan for coverage, then you might go for like design professional. If you want to become an instructor in Wi-Fi, then they could be like a network instructor certifications. There are several certifications that you can go for. If you go to the CWNP website, those who are interested in certifications, you can go for it. I myself did one of these certifications many years ago when they I think it was the first year when they came out. I also did one of these certifications many years ago. It's pretty cool, right? And I think you'll learn a lot of cool things there. So in summary, so I just talked about the kind of the general ecosystem from a company's and standardization point of view. We talked about the standards and amendments, which is primarily IEEE 802.11 and all the amendments. And then once the technology is standardized, we have certifications and PlugFest, Wi-Fi Alliance, WBA, Broadband Forum, and all of that. And then there are technologies that are doing open source technology like OpenWRT. Some of you who are in the Wi-Fi space might know that. OpenWiFi, Open Mesh, Open Roaming, RDKB. There are all these technologies, and I'm not going to talk about all of this in the interest of time, but there is so much here to learn in these areas. And then there is the public sector initiatives. There are city mesh networks that are deployed by governments. There is WANI program that is there. And then we have companies that are doing events, summits, podcasts. We talked about WLAN Now, Wi-Fi Knowledge Summit, which is another one that happens in Bangalore. I've attended those some sessions for the last couple of years. An excellent opportunity for the Wi-Fi experts to meet. I think it happens once or twice a year. I don't remember, but it happens here in India as well. Mobility Field Day, WLAN Pros Conference, podcasts, and so on, right? And then if you're looking for certifications and so on, then there is CWNP, which is more of a industry neutral certification. And then there are Cisco's, and there are all the big companies offer certifications, skill certifications. Cisco has CCNA and CCIE wireless and all of that. And then Aruba has some certifications. Juniper has some certifications. There are all big companies have certifications as well, right? So this is the idea in this particular section. We covered a lot of this material. From the next section onwards, we will here are some references, right? That will be posted as well. You can go through these references. But from the next section or the next session that is coming up Thursday, we are going full technical, right? And we'll try to make it as easy for people to understand. But we talked about everything around the access point, right? Everything around Wi-Fi device, right? We talked about standards, history, who uses that, what is the ecosystem, how is it standardized, how is it deployed, various topologies. We talked about so many things in the last 3 sessions. Now, from now on, all the other sessions is about this guy, right? So, okay, what is inside here, right? How does this function, right? The software that runs on it, the hardware, how it works, how antennas work, how the radios are laid out in this thing. What is the function of a radio? What is the function of baseband? What is lower MAC? What is upper MAC? How does the different interfaces work on this? What is the difference between an access point and a router, right? What are frequencies, the physical layer technology, right? What is medium access layer technology? All these things we'll cover in all these coming sessions, and we'll try to keep it as practical as we can by explaining using real world examples and showing packet captures, showing real devices, opening a real device and showing what's inside it. We'll try to keep it as practical as we can without a lot of, or actually I'll try my best not to have any formulas or equations, just concepts, right? And some practical application of these concepts. So that is about what we have in this session. I'll turn it over to the moderator for the quiz. Thank you.